Assalamualaikum and hello everyone. In today's online class, we are going to look at the last subtopic in chapter 1, which is 1.4, charges in a uniform electric field. So we are going to look at how charges behave when we put them in a uniform electric field. So this uniform electric field, it exists in a parallel plate of positive and negative. So when we have a positive plate and negative plate, the electric field in between the plate will be uniform. So there are 4 cases for this under this subtopic, so we are going to look at it one by one. So the first one is for the case of stationary charge. When we have a positive charge, when we place this positive charge inside the uniform electric field, what happen is, charge secara naturalnya dia akan attracted to charge yang different sign. So positive will be attracted to negative. So what happen is, there will be a force. There will be a force exerted on this particle. So when this positive is attracted to the negative plate, this charge will be moving towards this negative plate. So there is a motion. So this motion is in the same direction as the electric field. So the force will be in the same direction as the electric field, since electric field adalah daripada positif kepada negative. Next one is when we have a negative charge pula. So when we put a negative charge inside the uniform electric field, so naturally it will be attracted towards the positive plate. So there will be a force exerted and the motion will be towards the positive plate, which is actually in the opposite direction to the electric field. So electric field still sama, from positive to negative, dia tidak akan berubah. That's how the electric field behaves. So when we have these charges moving, when we have these charges moving and we have a force exerted on this particle, it is actually obeys the Newton's law of motion. So Newton's law of motion, which is the sum of force is equal to ma. Why do we have this one? Is because there is a motion, so this charge is moving, so there will be an acceleration, and this charge also has a mass. So that's why we are going to use this F is equal to ma. And since we only have one force, and this force is the electric force. And remember the formula for electric force, F is equal to QE. So when we substitute that one, QE will be equal to ma. So the acceleration of this charge will be equal to QE divided by m. So we are going to use this formula in case for the stationary charge. So next one, we look at the next case, which is when the charge is moving perpendicularly to the field. So perpendicular here meaning that when the field is, let's say the field is going downward, going to this direction, so the charge, let's say positive charge, is going perpendicular. So going perpendicular meaning that it is 90 degree. So let's say if we have a positive charge here, and initially this positive charge is moving with a with an initial velocity, some velocity, initial velocity. So as it enters the field, what happen is, this positive charge will be deflected towards the negative charge, because the positive will be attracted to the negative charge. So they will be deflected along a parabolic path. So dia akan deflected dekat sini, and then there's a final velocity here. So this is what we call a parabolic path. So it will move along a parabolic path towards the negative plate. So this is what happened for the positive charge. Let's say we have a negative charge. Let's say we have a negative charge with initial velocity of u. So as this charge enters the field, it will also deflected towards the positive charge dekat sini. okay, with a final velocity of v. Okay, kalau kamu perasan dekat sini, I just invert the positive and negative. So this one positive dekat atas, negative dekat bawah, and for this one is negative dekat atas, positive dekat bawah. So always negative akan attract to positive. So positive akan attract to negative here. So it will be deflected along, okay, a parabolic path towards the positive plate. So apabila kita motion of the charge is on a parabolic path, okay, remember again what we learned in semester 1. Okay, this one is actually obeys the kinematics law. Okay, kinematics law, which means kita akan ada x component and y component. So x component, okay, for Vx, okay, it will be the same. Vx will be equal to Ux, but for y component, since initially this charge only moves in the x direction only, so there is no y direction, meaning that uy dekat sini will be equal to 0, and then okay, a dekat sini adalah acceleration. So acceleration macam yang kita bincang tadi, acceleration is equal to, okay, QE divided by m, where Q here will be the value of the charge. But for this case, okay, A dekat sini adalah sama dengan, A will be equal to, okay, the number of electron times with the electric field divided by the m, which is why kita akan dapat this one. So final, okay, formula is Vy is equal to number of electron times with electric field divided by m, and T here will be the time taken. Okay, for displacement, so tadi adalah velocity, now displacement for x component still the same, as x is equal to uxt, but for y component, okay, we are going to use this formula, which is sy is equal to uyt minus 1 over 2 at square. Okay, di mana uy dekat sini adalah kosong, so we're left with sy is equal to negative 1 over 2. Still the same, a ni kita akan substitute with the formula of acceleration. Okay, with the formula of acceleration here, so we're left with sy, which is equal to negative 1 over 2 e number of electron times with electric field divided by mass, okay, t square, time taken. So that will be the explanation for when the charge is moving perpendicular to the field. Okay, next one is for the case when the charge is moving parallel to the field. So tadi tu kita tengok apabila dia move perpendicular, which is when it is 90 degree. So this one is when this charge is moving parallel to the field. So field ni, it is going from positive to negative. So motion dia sama juga, mesti follow the electric field. So when the motion, sorry, this one is v. So v, which is the velocity. So when the motion is parallel to the electric field, okay, so what happened is when we put the positive charge, so force will be attracted to the negative plate. So meaning that here the electric force, okay, so on the positive charge is in the same direction as the motion there towards negative. So meaning that here what happened is this positive charge will accelerate along a straight line. Okay, so what happened when we put a negative charge here? So when we put a negative charge and the motion is still parallel to the field, motion adalah sama dengan electric field, what happened is, okay, the force will be attracted, okay, the negative charge will be attracted to the positive plate. So bermaksud dekat sini electric force on this negative charge is in the opposite direction to its motion. Motion dia adalah, okay, sama direction dengan electric field. So meaning that this negative charge actually decelerates along a straight line. Okay, so this is what happened when we place a charge, a positive charge and negative charge in, okay, moving to the same direction as the field. So now let's look at the last one, is when this charge, okay, when this charge is in dynamic equilibrium. So dynamic equilibrium here means is when the charge moves with a constant velocity. So let's say we have a negative charge here, and then this charge is moving with a constant velocity. So what happened is, okay, as it goes, okay, as it enters this uniform electric field, okay, it will just move along a straight line. Okay, why does it move along a straight line? Is because, okay, actually there is a force exerted on this, okay, because this one is negative, so there is a force exerted on this, which is force, electric force, which is negative, attracted to the positive plate. And also there's also a force exerted going downward. So this force is actually what we call as the weight of the charge, which is W. So W here will be equal to mg. Okay, since these two are in equilibrium, that's why they were cakap dekat sini in equilibrium. So there, if it is in equilibrium, meaning that, okay, the sum of force will be equal to 0. So the acceleration will be equal to 0, which is why we only have a constant velocity. So apabila dia sudah dekat sini, still the value of the velocity will be the same, which is constant. Okay, so as you can see here, the negative charge particle will experience electric force of F is equal to Q, which is, this one is the electric force towards the positive plate, and the weight, okay, which is going downwards. So when this one moves in a straight line, but they moves in a straight line with a constant speed, and we only have for y component only, y component F plus W, which is equal to 0. Sorry, F minus W, which is equal to 0. This is the sum of the y component, which is equal to 0. So F will be equal to 0. So F is equal to QE and W is equal to mg. So we will get, okay, the final formula to get the mass for the charge, which is equal to QE divided by G, which is what you can see here. Okay, M is equal to QE divided by G, and G is the value of gravity. Okay, so that is all for the explanation for 1.4.